Imagine you are strapped into a capsule. It's twilight. Your heart is just pounding against your ribs.
Right.
And you are sitting at the very top of the 322-foot skyscraper that is essentially about to explode.
Which is a terrifying thought.
It really is. I mean, it's an engineered, carefully calculated explosion, of course, but it is still this violently raw release of energy, one that will completely and physically sever your connection to everything you've ever known.
And the wild thing is, you are actively, voluntarily inviting that explosion.
Yeah.
Because it is quite literally the only way to leave the planet.
Yeah.
I've actually set my studio backdrop right now to a glowing launch pad at twilight, just to try and, channel a fraction of that exact feeling of anticipation, that visceral mix of profound terror and just absolute undeniable awe.
It is entirely awe-inspiring. So welcome to the Deep Dive. Today we are taking you inside the Orion capsule of the April 2026 Artemis 2 mission.
The big one.
Exactly. We're pulling from an incredibly detailed breakdown, recently released by a YouTube channel called The Secrets of the Universe.
They do great work.
They really do. They compiled the day-by-day imagery, the logs, and the raw data of this historic flight. But our mission for this deep dive isn't just to, rattle off a list of hardware spec.
Right. No one wants just a table of contents of the trip.
Exactly. We want to take you past the headlines to experience the psychological and the scientific journey of the first humans to leave Earth's orbit in over 50 years.
It's really about synthesis. We are looking at what happens to the human mind and to our broader scientific understanding of the cosmos when we push ourselves entirely off the map.
Yeah.
We're looking at the absolute extremes of human endurance and observation.
Okay, let's unpack this, because we really have to start with the sheer physical reality of leaving Earth on day one. When you look at the Space Launch System, the SLS rocket, it's a 322-foot behemoth.
It's massive.
Right. But I struggle to wrap my head around the actual engineering margins here. How violent is this departure compared to, say, the Apollo missions of the 1960s?
Oh, it is a massive step up in sheer force. I mean, the SLS weighs 5.75 million pounds, fully fueled. Yeah, so when a vehicle of that mass ignites, it doesn't just lift off. It literally alters the seismic environment for miles. It is significantly more powerful than the Saturn V rocket that took the Apollo astronauts to the moon.
That is just hard to fathom.
It is. And what is staggering from an engineering perspective is the timescale of the acceleration. To achieve low Earth orbit, the engines have to accelerate 4 human beings to nearly 17,000 miles per hour.
Wait, 17,000?
Yes, 17,000 miles per hour in just 8 minutes.
8 minutes? That's like a drive to the grocery store.
Right. 8 minutes of absolute zero margin for error thrust. There is no pausing. There's no pulling over.
No hitting the brakes.
Exactly.
Yep.
The physics demand that every single component functions perfectly under unimaginable thermal and acoustic stress. And then, at the end of those 8 minutes, absolute silence.
Wow.
The engine's cut off. The boosters are gone. You are completely weightless.
But at that point, on day one, they were still essentially in Earth's backyard, right? The real point of no return came on early April 2nd, during the translunar injection burn.
Yes. At the TLI.
This is the moment I keep visualizing. It's like when you're merging onto a dark, completely empty highway late at night and you watch your hometown fade in the rearview mirror.
I love that analogy.
But in this case, the hometown you are watching fade away is the entire human race.
That analogy actually perfectly illustrates the physics of the translunar injection. Gravity is essentially an invisible tether pulling you back toward your driveway.
Right.
That single sustained engine firing snips the tether. It provided the exact amount of kinetic energy needed to overcome Earth's gravitational well. After that burn, there was no turning back.
They were locked in.
Completely. The orbital mechanics dictated that they were going to the moon whether they wanted to or not.
And the immediate result of that severed tether was this profound shift in perspective. Commander Reed Wiseman picked up his camera right after that burn and took a photo of Earth.
A phenomenal shot.
It is. And you look at that photo, and it's radically different from the pictures you see taken from the International Space Station. On the ISS, Earth looks incredibly close. It fills the window.
It looks deeply familiar.
Exactly. But in Wiseman's photo, you see the full disk of the planet. The clouds, the oceans, but it feels strangely distant. It looks like an object that is actively being left behind.
And that increasing distance sets up what happened later on day 2, yielding a photograph that, frankly, is a scientific goldmine.
Oh, the impossible photo.
Yes. Because of their trajectory away from the planet, Earth eventually moved directly between the Orion capsule and the Sun, which heavily backlit our planet.
I stared at this image in the source material and my brain just kind of stalled. The atmosphere is lit up in this razor-thin glowing arc around the black edges of the Earth.
It's beautiful.
And that would be a stunning shot on its own, but then you see the rest of the details. You've got two separate auroras glowing simultaneously in different corners of the frame.
Right.
And then in the lower right, there's this faint, massive, pyramid-shaped glow in the darkness. What exactly is that glowing pyramid?
What's fascinating here is that faint glow is known as the zodiacal light.
Zodiacal light, okay.
Yeah, and it is incredibly rare to witness clearly. It's essentially sunlight scattering off of ancient microscopic solar dust.
Dust?
Yes, dust that is spread along the orbital plane of our solar system. It's debris left over from the formation of planets and from passing comets.
Wait, why have I never seen that looking up at the night sky?
Because you live at the bottom of an ocean of air. Our skies, even in the darkest terrestrial locations like the Atacama Desert, are simply too flooded with light pollution, moonlight, and atmospheric scattering to see it clearly.
Oh, that makes sense.
So to capture the curvature of the Earth, two separate auroras, and the delicate zodiacal light all in a single frame, it requires a vantage point utterly divorced from our atmosphere. It proves just how much visual data we miss simply by being stuck on the ground.
That is wild. And that theme of being divorced from Earth really takes over next. The violent physics of leaving completely fade away, and the mission enters what the source material beautifully describes as the silent middle.
The space between worlds, days 3 through 5.
Yeah.
I'm shifting my backdrop now to just a dark, seemingly infinite starry void.
Yeah.
Because that is exactly what their reality became. The physical thrust of the rockets is over, and an overwhelming psychological stillness takes over.
The visual contrast is stunning. On day 3, out the rear window, Earth is shrinking down to a crescent. Out the front window, the moon is steadily growing.
Delicate balance.
But what struck me the most weren't the photos of the celestial bodies themselves. It was the photos of the cabin interior.
Oh, yes. The dark cabin.
Right. The crew turned off all the interior lights, plunging the capsule into total darkness just to eliminate the glare on the glass so they could see outside.
Which resulted in this haunting image of astronauts Christina Koch and Jeremy Hansen. They're floating by the window, and their faces are illuminated only by the soft, blue glow of a computer monitor. They're just staring out into the void. Earth has been reduced to a sliver. It is literally just a thread of light in the darkness.
I have to pause here because this specific photo really caught my attention. Usually, space agencies love to pump out these high-resolution, perfectly lit, triumphant photos.
Oh, absolutely. The PR shots.
Yeah, telemetry data on screens, pristine hardware glinting in the sun, astronauts smiling. Why do you think NASA intentionally released these dark, grainy, profoundly human photos of two people just quietly staring out a window?
Because I think they realized the psychological narrative is just as important as the structural one. The silence of the middle journey is a uniquely heavy burden. When you are coasting on that trajectory, you belong nowhere.
You're just in between.
Right. You are no longer part of your departure point, but you haven't yet reached your destination. It's an existential limbo, and you can see that weight in their posture.
That makes a lot of sense.
And by day 4, there's an image taken from a camera mounted on the outside of Orion's solar array wing, looking back in at the capsule window.
Ah, the outside-in perspective.
Yes. You see Jeremy Hansen with his face pressed hard against the glass looking out. When you see that image, the reality clicks.
It really does.
You realize the nearest solid ground to that man is hundreds of thousands of kilometers away in every conceivable direction. He is completely untethered.
And by day 5, Earth is barely even a visible arc. But that quiet, that heavy existential silence of the middle journey is violently interrupted by their arrival on day 6.
The sheer scale of the moon just takes over.
Yeah, that profound emptiness makes their encounter with the moon so visually jarring. Because they don't just slowly approach it. Orion enters its lunar flyby and suddenly skims just 4,000 miles, about 6,500 kilometers above the lunar surface.
Which is incredibly close.
Exactly. How do they get that close without getting pulled into orbit and trapped there?
They utilize what's called a free return trajectory. Think of it like throwing a boomerang around a pole. They don't use a massive engine burn to slow down and enter a circular orbit around the moon. Instead, they carefully aim the spacecraft so that it falls slightly behind the moon.
Oh, I see.
They let the moon's gravity grab them, swing them around its far side, and slingshot them directly back toward Earth.
That is wild.
It's an elegant use of orbital mechanics. It saves fuel, and ensures a safe return even if the main engines fail. But because they skim so close during that swing, the moon stops being a glowing orb in the distance. It becomes a massive, looming, fast-moving landscape outside the window.
And the visual data they captured during that swing is just unprecedented. The first major geological feature they hit is the Orientale Basin.
Yes, a spectacular sight.
It's this 600-mile-wide impact scar sitting right on the boundary between the near and far sides of the moon. It's filled with this dark, ancient lava.
And right next to it, there's a neighboring crater throwing out massive rays of ejected debris that stretch for 250 miles across the surface.
Just a completely brutal landscape.
It is the frozen aftermath of an impact so violent that it scattered ejecta across a quarter of the visible lunar surface. But the visual clarity of these formations gets even better as Orion crosses what is known as the Terminator line.
Here's where it gets really interesting. The Terminator line is the boundary between the sunlit side of the moon and the side plunged into the darkness of space.
Right.
Because the sun is hitting the surface at such a low grazing angle right at that boundary, it creates this incredible 3D relief.
The shadows become super exaggerated.
Exactly. Think about taking a really bright flashlight and laying it flat against a textured stucco wall in a dark room.
Oh, that's a great way to picture it.
Suddenly, every tiny bump casts a long shadow. Mountains, valleys, and terrace walls that are completely washed out and invisible under direct overhead sunlight suddenly pop out like a meticulously carved sculpture.
And if we connect this to the bigger picture, this kind of sculptural lighting is vital. It gives geologists a pristine, frozen record of the violent early days of our solar system.
Because nothing changes up there.
Right. Because there is no wind, no flowing water, and no plate tectonics on the moon, the surface doesn't erode. Those central mountain peaks and highland terrains haven't changed a single inch in 3 billion years.
And speaking of those peaks, they flew right over Vavilov crater, which sits permanently on the far side of the moon, completely invisible from Earth.
A very special crater.
Wait, hold on. The source material mentioned that during the formation of this crater, the solid rock of the moon actually behaved like a liquid, and the central peaks are a rebound.
Yes.
I'm having trouble picturing that. How does a meteorite impact turn a solid lunar surface into something that ripples like a puddle without actually melting it?
It's a fantastic question, and it comes down to a physics concept called kinetic energy transfer during a hypervelocity impact.
The hypervelocity, okay.
We are talking about an asteroid striking the moon at tens of thousands of miles per hour. At those speeds, the kinetic energy is so unimaginably vast that when it hits, it generates an acoustic shockwave that temporarily overcomes the structural strength of the rock itself.
So the rock just stops acting like a solid.
Exactly.
Yeah.
While there is a flash of localized melting, the vast majority of the rock behaves plastically. The shockwave literally shatters the crystalline structure of the bedrock.
Wow.
For a few incredibly chaotic seconds, the rock acts fluid dynamically. It gets pushed outward by the blast, creating a massive bowl, and then the center rebounds upward.
Kind of like when a drop of water splashes into a puddle.
Exactly like a drop of water bouncing back up into the air after splashing.
Yeah.
But because the shockwave passes so quickly and the energy dissipates, that rebounding liquid rock instantly freezes back into place.
Creating those massive solid central peaks.
You got it.
That is deeply unsettling clarity. I mean, they are looking at features formed in the first chaotic seconds of an impact, perfectly preserved forever.
It's a true time capsule.
But as they marveled at this hyper-violent geologer, the mission brought another, much more sobering milestone in part 2 of Day 6, Earthset.
Yes. Earth sinking behind the jagged edge of the moon.
Everyone knows the famous 1968 Apollo 8 photo of Earthrise, our vibrant blue marble rising over the dead lunar landscape.
Right. Earthrise was a moment of absolute revelation. It birthed the environmental movement.
But Earthset was a quiet, creeping disappearance.
It's a completely different emotional tone.
The crew filmed it, and watching the video, the sense of scale hits you completely differently than a still photo. Earth doesn't just vanish instantly.
No, it's gradual.
It slowly, agonizingly sinks behind the ancient cratered surface until there is nothing left in the window but the dead gray moon and the blackness of deep space.
And the moment Earth finally disappeared, the radio died.
Just total static.
Orion crossed entirely behind the moon, slipping into the true dark side. There were 2,200 miles of solid, dense lunar rock completely blocking any radio signal to Earth.
So mission control in Houston just went completely silent.
Completely silent. For nearly 40 minutes, those 4 astronauts were undeniably the most isolated human beings in the entire history of our species.
No contact, no telemetry, just the crew, their spacecraft, and the far side of the moon silently sliding past the glass.
Incredible isolation.
But the moment they finally clear the far side and regain contact with Houston, they are immediately thrust into one of the most intense scientific opportunities of the entire trip.
The Great Eclipse.
Yes. From their unique vantage point, the moon perfectly blocks the sun. And unlike a total solar eclipse on Earth, which might give you, a maximum of about 7 minutes of totality?
Around there, yeah.
The Artemis II crew experienced 54 continuous minutes of totality.
54 minutes. That is a staggering, unheard of amount of time for this specific observation. They were able to photograph the sun's blazing outer atmosphere, known as a corona, along with Venus and Saturn, with absolute zero atmospheric interference.
I have to ask, how do you balance that?
What do you mean?
As a crew member, how do you process the existential dread of watching your home planet disappear, surviving the most profound isolation in human history, and then suddenly pivoting to the intense pressure of having exactly 54 minutes to capture unprecedented, unfiltered data of the sun?
You rely on your intense training, certainly.
Yeah.
But you also rely on the sheer magnitude of the scientific mystery sitting right in front of your camera lens.
Right.
This raises an important question that solar physicists have been battling for decades. The mystery of the corona itself.
Okay, lay it on me.
The sun's visible surface is incredibly hot, obviously, but the corona, the wispy outer atmosphere surrounding it, is hundreds of times hotter.
Wait, the outer atmosphere is hotter than the surface?
Yes.
That completely defies basic thermodynamic intuition. If I walk away from a blazing campfire, the air 100 feet away isn't magically hotter than the coals? How is that even physically possible?
And that exact campfire analogy is why solar physicists have been losing sleep over this.
Yeah.
The visible surface of the sun is roughly 10,000 degrees Fahrenheit. But when you move out into the corona, further away from the nuclear furnace at the core, the temperature violently spikes to over 1,000,000 degrees.
Over 1,000,000. Okay, so what is superheating it?
The prevailing theory centers on a mechanism called magnetic reconnection. The sun isn't a solid object. It's a swirling, churning ball of plasma.
Right.
And as that plasma twists, it creates incredibly intense, tangled magnetic fields. Think of them like tightly wound, invisible rubber bands stretching out into the corona.
Oh, I see.
When those twisted magnetic field lines cross and snap under the tension, they violently reconnect.
And that snapping releases energy.
Exactly.
Yeah.
A massive burst of stored kinetic and thermal energy gets dumped directly into the surrounding plasma of the corona, superheating the particles.
Wow.
But to actually prove and observe the intricacies of this, scientists chased terrestrial eclipses all over the globe just to get a few fleeting minutes of blurry data through our hazy atmosphere.
And these guys had almost an hour.
Nearly an hour, in a perfect vacuum with custom-designed optics. The data from those 54 minutes will rewrite textbooks.
That's incredible. But what I love about this mission, what really elevates it from just a clinical scientific expedition to a profoundly human story, is what happened next, around days 7 through 10, the return journey.
The human element really takes over here.
It does. The climax of the lunar flyby wasn't just orbital mechanics and thermal imaging. Before they began the long coast home, mission specialist Jeremy Hansen keyed the radio to mission control, and his voice was thick with emotion.
Right.
He requested permission to formally name 2 craters they had spotted near the Glushko region.
The first they wanted to name Integrity, as a nod to their spacecraft and the massive team back on Earth.
A great tribute.
But the second crater, a bright spot right on the moon's near far side boundary, they requested to name Carol.
Carol Taylor Wiseman. She was Commander Reed Wiseman's late wife.
Yes.
She was a neonatal ICU nurse who passed away from cancer in 2020 at the age of just 46. You can hear the raw weight of it in the audio logs. Wiseman himself was far too emotional to speak.
The crew just floated there in the cabin in a quiet embrace, tears on their faces.
And Houston went silent for nearly a full minute before coming back on the loop and officially approving the names. Carol Crater.
It is such a poignant contrast. A permanent, impossibly bright geological monument on the surface of a dead, silent world, dedicated to a woman who spent her life caring for the absolute most fragile, vulnerable human beings down on this noisy world.
That deep sense of perspective carries right into their journey home. By day 7, as they are moving away from the moon, they take a photograph looking out at the Milky Way.
Ah, yes.
From Earth, on a perfect moonless night in the deep desert, we might see a faint, milky smudge across the sky.
If we're lucky.
Right. But the photo they took from Orion captured the galaxy stretching 100,000 light-years across the frame, exploding with dense star fields, utterly unfiltered by atmosphere or light pollution.
Stunning. NASA released the image to the public under a simple two-word title, Starstruck.
A perfect description of the overview effect in action.
Absolutely.
And then the long coast back eventually leads to day 10, April 10th. Splashdown.
The final hurdle.
They hit the Earth's atmosphere at nearly 25,000 miles per hour. How does the capsule even survive that friction without burning up like a meteor?
It relies on ablative shielding. As they slam into the thickening air, the friction generates a plasma sheath around the capsule.
Right.
That creates temperatures comparable to the surface of the sun. But the heat shield is designed to intentionally slowly burn away or ablate.
So it sacrifices itself.
Exactly. As the material burns off, it carries the extreme thermal energy away from the spacecraft, keeping the interior cabin completely safe. It's a terrifying, fiery descent that ends with the gentle deployment of parachutes, splashing down safely in the Pacific Ocean.
So what does this all mean? When you look at the entirety of the Artemis 2 source material we've gone through today, you see this incredibly stark duality.
Oh, definitely.
On one hand, you have the absolute apex of human engineering and cold physics, a 5.75 million pound controlled explosion, pinpoint orbital mechanics, hypervelocity lunar geology, and surviving solar surface temperatures on reentry.
The hard science.
Right. But on the exact other hand, right in the middle of all that brutal math and vast emptiness, is the deeply fragile, purely emotional need to memorialize a lost loved one on a bright crater 240,000 miles from home. It's the ultimate synthesis of our technology and our humanity.
It truly is. And it's important to remember that this mission wasn't just the ultimate test flight for a rocket. It proved the life support systems, the navigation, and the radiation shielding for what comes next.
Because it's not stopping here.
No, because Artemis 3 is targeted for 2027, where they will test docking the Orion capsule with commercial lunar landers in Earth orbit. And that completely sets the stage for Artemis 4 in 2028.
The big return.
The first time human boots will touch the lunar dust since 1972.
It is staggering to realize what humanity just achieved with this flyby, and even wilder to think about what is literally right around the corner. So thank you for joining us on this incredible deep dive into the Artemis 2 mission logs.
It's been a journey.
The next time you find yourself strapped into a seat, waiting for a journey to begin, think of that Twilight launch pad. Think of the sheer bravery it takes to watch your entire world shrink down to a sliver in the dark.
And I want to leave you with one final thought to mull over. We just discussed the profound isolation of Earth's set and the psychological overview effect experienced by these 4 astronauts staring out of a darkened cabin.
Yeah.
But think about Artemis 4 in 2028. When humans finally walk on the lunar surface again, they will be broadcasting that fragile view of Earth back to a society that is infinitely more hyperconnected, yet significantly more fractured than it was in 1972. How will seeing our single, borderless blue marble in the Boolean Live 4K definition reshape the way we interact with each other down here on the ground?